Hello, today on this one we're going to be doing my new TV build, and there's going to be a couple different videos with regard to this for selection of each of the different components and testing of those components. Like specifically, I'm going to have one talking about the Grand Vision, one about the motherboard. I'm not going to do specific ones about the power supply or the CPU, but I'm going to talk about each component, so I hope you'll join me on this adventure. All right, so going over the components that are being used in this build. I got the Be Quiet Power Zone 2 850 watt. Now the GPU that's going in this is going to be my old RTX 3070. So this power supply is supposed to have PCI, or not PCI, ATX 3.1. So it's got the newest version of the 12 volt high power cable for newer GPUs. Of course, things are subject to change, so can't really future proof. And it's also compatible with dual 8 pins PCI power, which is what the 3070, so it'll handle my current and future GPUs that I'll stick in this thing. All right, next, the RAM that I got, T-Create. I use this in my personal build. It's 32 gigs, which is well more than enough, and pretty fast timings on it. I forget exactly, oh, there it is, 6,000 mega transfers per second. So it's CL30s, so it's got very tight timings. So again, I'm gonna have a separate video about this, AIO, but I'd like to thank Thermalright for sending me this as a review sample. I've had this for quite some time, but since I didn't have a build to put it in, I couldn't really test it, and it's going to go into this one. Unfortunately, the CPU that's going to be hooked up to initially isn't really going to overload this thing, so it's just going to be a pure silence, but I'm going to go over it in a separate piece. SSD of choice, or M.2, is a 4 terabyte T705, so it is a Gen 5. Chose it because it's a pretty speedy Gen 5 without breaking the bank, and so just kind of a simple choice there. The CPU is going to be an AMD, so I'm going to be, the reason for the AMD is actually so I can tier my system. So right now my current gaming system is a 9700X, and this is a 7600, and the idea is that I can turn this into a test system for my my case simulation type testing with a passive heatsink. So I needed something that was low power and relatively inexpensive, and since it's going to be TV box with a 1080p TV, didn't really need to be super powerful, but that means with the motherboard's AM5 socket, I can use the current CPU and swap it into this motherboard, and this will go into another one, and just do step-down method. Of course, that is subject to change based on how well AMD continues to do in terms of compared to Intel. But that is the idea, and why I ended up choosing the 7600X as my CPU. Fairly fast, 6-core, can be downclocked to 65 watts for efficiency or boosted for like 100 and something watts. So again, the AIO will be more than a match for it. My motherboard, and I'm gonna have a separate piece on my motherboard analysis, is the TUF Gaming X870 Plus Wi-Fi. So I'll go over why I ended up choosing that one in that separate piece. But this is the one I ended up choosing because it was cost effective while giving me the full features that I wanted. And last but not least, Meshify X3 XL for the computer case, because I just really liked the way it looked. All right, so for me, for this particular build, my build process has been to install the power supply first with the applicable cables, because I just found it getting in there a little bit more challenging. Normally, I would wire up the motherboard and then fish it through and then plug it in. But for this case, so this bracket comes off, you give it the proper orientation, and the power supply can either face up or down. It has proper ventilation from both sides. All right, so now we're going to take the motherboard out. So I am going to be pausing intermittently in here because I'm holding the camera one-handed. So excuse that. Okay, I got everything out of the box. We got SATA cables, we got whatever these things are, stickers, and the Wi-Fi antenna, I suppose, and of course the manual. So we'll need to consult this to make sure we use the proper RAM. And of course the motherboard itself, and as a good anti-static surface to start building on, you can use the top surface of the box. All right, so this is the motherboard. Got the protective cap. Go ahead and release the lever. Just push down, lift out, rotate, and then this comes up, and it's a good idea to always inspect the socket and look for any damage. All right, now to install the CPU, there should be a little golden triangle right up there in the corner, if my focus will work. And there's a triangle right here on the CPU, so you just line them up. I'm not going to drop it in one-handed, so you're just going to have to see the end result. Okay, now the CPU is in, and you can close that, and you can go ahead and leave this cap in place, and as we pull it down, it just pops right off. And now the CPU is good and firmly installed in place. Okay, referring to the manual, and apparently lighting sucks, but A2 and B2, so I'm gonna go right there and there for the RAM modules. And I have the RAM kind of out now. Let's see, I'm not going to be able to fully install it with one hand without potentially breaking anything. But here's a RAM module. There's a little groove right there, and you just line it up. If it does not line up, then that is in the wrong way. So this motherboard right here, these bottom ones don't slide out, so it just slide down into place. And you know, you can kind of see if it looks like it's going to line up, and don't try to ram it into place if it isn't. If it isn't lined up, you have it backwards, like it is probably right now. All right, so I got it lined up properly now. You can see that there's the silver shine lines up with that, and then you just give it a good lock into place. Make sure that's good in there. And we do the same thing for the other side, our other module. Okay, both sticks of RAM are installed. And then you can consult your manual again to make sure you install in the proper M.2 slot. For this one, it's pretty obvious that it's going to be this one. And there are two more underneath this other heatsink. All right, to install the M.2, see how there's a grid pattern on the M.2? Well, there's going to be a pattern on the little slot right there. And so you just make sure everything is rotated in the proper direction. Put it in, slide into place, and then you bring it down, and you get everything lined up, or you put a screw into place. As a note here, don't forget to peel the peel off of the thermal pad on the back of these metal plates, just to improve efficiency of that thermal transfer. Otherwise, it's going to act as an insulator there. All right, so now we're at the crossroads of, do you install the CPU cooler, or do you mount it in the computer case? Depending on what kind of build you're doing is the order you want to do it. I personally do air coolers outside the computer case, but since I'm going with an AIO in here, I'm probably going to mount everything in here first, and I need to remove these brackets and keep the back plate per this is instructions, and we'll kind of go from there. Okay, so I'm going to mount the motherboard in first before doing the cooler, just so the cooler housing doesn't whack into anything, or I feel that it'll be less likely to. So, okay, let's do that. All right, the motherboard is not screwed into place, so you want to be very careful and not wiggle it around, because you don't want to scrape the back because it could damage traces. So very carefully and gently line it up, and then once you feel it's in the right place, that's when you screw it in. Before I go and install the cooler, I'm going to plug in as much stuff as possible while it's still easier to access, and then we'll go ahead and do that part. I'm not a super fast PC builder, but got all the cables in. The cable management stuff is looking pretty good, I would say. Took a while to figure out how some of these cables, so I have the top end edition of this case, and this cable, I was looking for the power LED for the button in the front, and I think it's this cable connected into this box, and the documentation is pretty piss poor, if I'm going to be completely honest, for exactly how this hub works and getting everything connected to it. So just deciphering that took quite a while, but in terms of cable management, everything, you know, before it was a mess, and then I just sort of smushed it in, and now it looks pretty good, other than my CPU power cable. And if we rotate the case and run onto the front, this is still loose, so I'm going to tighten that into place. But all the cables are nice. Get this into position for where the CPU is going to go. And got my USB headers for the functionality of the fans in the front, as well as the CPU cooler, which is not installed yet. And HD audio, and you know, it's coming along. All right, and while I'm thinking about this particular AIO, there is not an AMD offset bracket. So it isn't the maximum cooling potential for AM5, because down here is where the CCDs are. All right, so my next step is going to be putting in the radiator for the AIO up here, and then we're going to mount it up. So you could probably do this vertical, but I'm going to lay it on its side just for ease and make sure nothing, you know, drops and falls. All right, now everything is installed other than the GPU. We're going to install it right here. Make sure, and you know, everything else looks pretty clean. Right now is the time to clean up everything in the case, in my opinion. Basic cable management, I'm pretty happy with it overall. Now that the GPU is installed, this is what the case kind of looks like with it still opened up. Now, this is huge. Look at all this empty space. So My choice in case was actually dictated by the fact that I had a cooler available to me. Again, thank you Thermalright for providing this. So the smaller case would actually kind of look better with standard components. If you're going to do a custom loop or fill the space with a fan or something like that, it would look better with that stuff. But unfortunately, I'm not doing that, at least not yet. So there is room to grow in this computer case. But I just want to point out, certain things about it. I bought it mainly for this flow guide. Gamers Nexus did a great review on it. And I completely agree. I can tell you as a aerospace engineer that air blowing from this will get deflected up into your GPU. And you can, having fans blow low and below and having channels to get air to the GPU, unless you design the case another way, with fans at the bottom blowing up, is a necessity. All right, I wanted to go over a little bit of my performance readings here off of 3D Mark's website. So the first one is performance through 3D Mark 11, and we have the newest one, then with the 11700K, and then my oldest CPU, the 6700K. The reason I'm comparing all three of these is they all have the same GPU, although the newest one did error out and not display the GPU in it. This is a trend with some of the tests where it just is missing some of the data, and I'm going to have to walk you through it with words as opposed to just looking at the picture. So we got the 3D Mark score. Obviously, the newest one is the best overall. But let's go to the graphics score. They're all very similar, but the newest computer with the 7600 does have the highest graphics score. Mind, we're only talking, if we actually take a look at the GPU tests, that one's almost 10. So about 5, maybe 10 sometimes. FPS higher, depending on the test. So is it meaningful? No, but it could raise its head in some gaming scenarios. And another thing here is the combined test. So with this particular GPU, my 6700K, that was a 4-core processor. I forget how many years old it would be. 2016? Is that right? Just is a bottleneck for it in the combined test, which is why it's so low. While it's interesting that there's a little bit of extra performance by going to the 7600 as opposed to the 11700. So let's go to the next test. This is the storage comparison. So the newest one, the T705, is over here on the left side. I forget what these two are in the middle, but I believe they're in the newest computer build. But needless to say, the only Gen 5 SSD is in the newest test, and it is a little bit faster, but my point here is that it's not significantly faster than the Gen 4s that are in the other machines here. Mind, the 11700 has only a couple Gen 4s and other Gen 3s, so there's a pretty big gap between the 11700 and the newer AMD-based systems that I have. All right, CPU comparison. So we have the 7600, the 9700X, the 11700K, and the 7945HX, which is a mobile 16-core CPU. So I just want to kind of do kicks and giggles, funny, comparing these things. So max thread count, or performance. The 7600 is at 7,000. I'm going to just ignore the hundreds in it and just do the thousands. The 97 is at 10. The 7945 is at 10. And the 11700 is at 8, indicating that the 11700 is slightly more performant than the 7600 in this particular test. And if we're both of them, so we're comparing an 8 and a 6 core, talking about those two. The 97 is an 8 core, just like the 11700. But so in one thread, they're all pretty close. In two threads, the 9700 starts to break away. In 4 threads, the 76 and the 117 are close to each other, with the 76 doing slightly better. By 8 threads, the 11700 starts to do better. So it's just interesting at the number of threads, how much application, so how much of the actual CPU you're using, how the performance changes between each of these processors. At least I find it interesting. We're going on to the next test. This is FireStrike. So we got the 3 computers plus my second newest build, I guess, with a 9700 and a 480 Super in it to show how bottlenecking kind of occurs, which is I think it's an interesting thing. So we got the 6700, and if we look at the combined test with the 3700, it was only getting 34.55 FPS. When we go to the 11700, it got 53.75. And when we get to the 7600X, it's getting 73.61. So I don't really think the 11700 was bottlenecking that particular GPU. So it could be something that coming up in this test. But it is kind of interesting that it rears its ugly head here. And I say that because in this test, because I have gamed on that computer a little bit, and I haven't noticed any FPS difference in big few games that I have on it based on what was on the 11700 version. So now this is FireStrike Extreme. I believe that this is operating at like 1440p, while the basic is more like operating at 1080p. So this starts shifting more load onto the GPU. So when we take a look at the combined test, they're all quite a lot closer. So again, bottlenecking in the CPU as opposed to bottlenecking in towards the GPU. And they all have it very similar. I think I repeated myself. With the 11700 and the 7600X being significantly closer than the 6700K, so indicating that there's still some bottlenecking going on there. But if you have a computer, it's not worth the expense to build a new one to save a little bit on your electric bill. And now we're onto FireStrike Ultra. So this shifts everything onto the GPU because it's operating at basically 4K, and we see it completely in the tests. And I know these are slightly different versions, but it doesn't really change what I'm saying about it. It would only be if we want to truly do like nitty-gritty apples to apples comparing each of the tests, but I'm more talking about the general trends here. So in the combined test, they all basically run at exactly the same FPS. There's just no meaningful difference, even in percent difference, because you've loaded it all onto the GPU and the CPU is not really having to work all that hard. Even you only notice it in the physics test by itself. So if you were to run emulator or extra mods onto a game like Skyrim and whatnot that utilizes the CPU performance to add physics to it, then you might see some difference there. Now we're onto Port Royal, and in 3D Mark score, the 67, the 117, and the 76X all score very, very similarly between the GPU, graphics, all the score testing. And then we're on to Time Spy, and once again the same order, 76, 117, and the 76X. I hope I'm saying the names right because they all kind of blend together. So CPU test, obviously, there's a bit of difference. And the 117 does have a higher performance level than the 76. So we've seen them trade places several times in these tests. So I personally think that the two of them ought to be treated as though they're basically equivalent in performance. In the graphics tests, they all score basically the same, which, again, makes a lot of sense. It's the exact same GPU. It's just lived in three different computers. And Time Spy Extreme, well, here is where the 67 kind of falls behind quite a bit from the other ones. Actually, no, it's a bit behind there too. But in the CPU test, it is just has a lot higher latency. Yeah. And even the 76 actually is a little bit slower than the 11700K. Like PCI Express Gen 3, 4, and 5 with each of these. But mind that GPU is PCI Express Gen 4. So even though it's on a Gen 5 system, I'm not getting Gen 5 speed out of it. All right, so here's the 7600X. And we want to take a look at the temperatures. Its average temperature was 62 degrees C across the entire test, running at average clock speed of just over 5,000 megahertz. Very similar actually to the 97 and faster than the 11700K. So at the 11700K, probably pulling 250 watts. Average temperature for this test, the 76 was at 62 degrees, which is better than the 68 degrees we saw in the 9700X, and the 97 is on an air cooler, while the 76 is on an AIO. I do have a separate piece specifically about the AIO, and I heard sloshing inside of it, so I think I have problems with it. So I am going to be looking at replacing that AIO because I think it's malfunctional. First, I apologize for the cramped nature where this is going to sit, but I wanted to talk briefly about the airflow that I have set up for how this computer case is. So this is where its final home is going to be, nestled right in there, and it is pretty long. Now, AIO on the top, like we talked about earlier in the video, 304 is at the front. So at idle and moderate load, so where the CPU is not getting very hot, it is actually full on positive. The air is pushing out the back. I can feel airflow, and I actually tested with my anemometer where air is coming out the back, as opposed, well, air is coming out the top, but what I mean by that is air isn't being sucked back in, particularly by this back fan position. So you can see the fans, 1, 2, 3. That was a major concern of mine, is I did not want this fan to be sucking in air from the top. And instead, I put my anemometer right here, and air was moving out to the back, which is quite ideal. Now, I will admit, at 100% fan speed, So in very high powered CPUs, like, I don't know, 200 plus watts, where these, on this 360 AIO, where we need to really crank things up. Again, I haven't gone into replacement yet, so I need to do an apples to apples to see if the replacement sloshes like the current one. So I could potentially get even better temperatures, but let's say I ran these fans at 100%. Well, in order to get air moving out the back, so a positive pressure on the inside, as opposed to it being negative where I'm sucking air back in, I would need to crank these front fans up quite a bit higher than they are right now. Right now, I just have it set to the motherboard's silent curve. So with the Fractal Design software, you set the kind of the percentile difference between their software with the controller in the back to the motherboard PWM fan signal. So you don't really get to directly control these, particularly with the fan control software, unless you directly plug it into the motherboard and then you lose the ambiance coloring effect. So if the coloring effect does matter to you, then you want to leave it by the controller control. If the color effect, particularly for the fans, does not matter for you, just plug it into the motherboard. You get more direct control over it and it will overall work better. For now, I'm leaving it via the controller because it seems to be doing just fine, because I have a very low powered CPU in here, and yada, 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 what we've been talking about already. Oh, so the main point, positive pressure, so the air is moving straight through the back, and the back is not acting as an intake, which is ideal in my opinion, because I don't want extra dust getting inside there. So yeah, the thing with this build is kind of this blue color. I liked it the best. And while we're here, because I said earlier on in this video that the CPU in here, the 7600X, will have a second life in probably about a year. When it comes time for me to upgrade my main gaming computer system, I'll have that CPU go into this system, and this CPU I'll pull and have a CPU cooler test. And that's where this heatsink will come in. This is the Noctua NHP1. It is the passive air cooler. So I'll have it in a test apparatus box, airflow goes across it, and so it allows me to very fine-tunedly test what fan would help cool the cooler the best, to get kind of a thermal data. So I acquired this basically way ahead of time because the price was right, and I didn't think the price, and I thought the price was going to go up. And I have an AM5 socket adapter coming in from Noctua. I did purchase this with what little money I've made via this channel. So if you like what I'm doing, please think about subscribing and helping support the channel, because well, I'll have to build an actual test system to do this type of testing. So if you like the idea, please think about it. And with that, I'm going to call it an end to this video. Thank you very much for joining me here. And well, I hope you subscribe and enjoy the videos that I continue to produce.